Welcome and study with Tanzania Institute of Education.
The topic is a confirmatory tests for the cations and anions. Introduction. Detection of cations and anions depends upon the availability of the salt in the form of solution. The preparation of the solutions of the salt during a preliminary test is one of great importance in the test of the cations and anions. After detection of the cations and anions, one has to confirm their presence by using other means. Aim of the experiment: to confirm the anions by the addition of a specific solution into a given salt solution. Requirements: apparatus: 5 test tubes containing the suspected anions, a test tube rack, and test tube holder. Chemicals: the bench reagents which are used to confirm the suspected salt solution. Procedure: to confirm the presence of nitrate, have to add a fresh prepared iron 2 sulfate and hold the test tube using test tube holder. Take concentrated sulfuric acid and add to the solution, and make sure that concentrated sulfuric acid has to pass to the walls of the test tube. The brown ring formed when the 2 layers meet. This shows the presence of nitrate in the solution. Then you take the solution containing sulfate, solution suspected. This tested by using dilute hydrochloric acid followed by barium chloride. You add a small amount of dilute hydrochloric acid, then followed by barium chloride solution. A white precipitate formed. This indicates the presence of sulfate ions in the solution. After that, you take the chloride ions suspected. To test the chloride ion suspected, you have to add silver nitrate solution a white precipitate formed. Take by addition of dilute nitric acid. Till in excess. The white precipitate formed is insoluble in dilute nitric acid, and this confirmed the presence of chloride ion in solution. The next is to confirm the presence of carbonate ion to the solution provided. In order to confirm the carbonate, you have to add magnesium sulfate solution. White precipitate formed, and also this indicate the presence of carbonate ions in solution. Lastly is you take bicarbonate solution suspected. You add magnesium sulfate solution. On addition of magnesium sulfate solution on hydrogen carbonate, no precipitate formed. Then you have to boil the solution. White precipitate formed when the solution boiled, and this confirms the presence of hydrogen carbonate ion. Expected results and observation were as follows. To confirm nitrate ions, add a fresh prepared and 2-sulfate followed by concentrated sulfuric acid gradually on the sides of the test tube. Brown ring layer forms between the two layers. To confirm sulfate ions, add barium chloride solution, then dilute hydrochloric acid. White precipitate forms insoluble in dilute hydrochloric acid. To confirm chloride ions, you have to add silver nitrate solution, then dilute nitric acid. White precipitate forms which is insoluble in dilute nitric acid. To confirm carbonate ions, you have to add magnesium sulfate solution, dropwise, then in excess. White precipitate forms. To confirm hydrogen carbonate ions, you have to add magnesium sulfate solution, then boil the solution. White precipitate forms after boiling. The results from the reactions as shown show the existence of a specific reagent which, when used, gives an observation which indicates only one anion present in that particular solid sample. All of the ions suspected during preliminary test and the weight test have to be confirmed. After confirming the anions present, also the cations suspected must be confirmed. The aim of this experiment is to confirm the cation suspected by the addition of a specific solution into a given salt solution. Requirements: glass rod, watch glass, test tubes containing the suspected cations solution. The reagents which stand for the chemicals used to test the cation suspected. Take the test tube which contain the suspected lead ion. To confirm the lead ion, add potassium iodide solution. Drop-wise, then in excess. After addition of potassium iodide solution, yellow precipitate formed, and this indicates the presence of lead ions in the solution. To confirm calcium ions, this will be confirmed by using flame test, and you have to use a solid sample. Take dilute hydrochloric acid, you put on the watch glass. Take the glass rod. If you have the platinum wire or nickel wire, you can use it, but here I am using the glass rod. You put into dilute hydrochloric acid, take the sample solid, put in the burning flame, observe a reddish flame. This indicates the presence of calcium ion. Take another salt. This is an 2 salt solution suspected, and to confirm this, add potassium ferrocyanide solution. A darker blue precipitate is formed, and this confirms the presence of iron 2 ion. Next is the confirmation test for iron 3 ion solution. To confirm this, you have to add potassium ferrocyanide solution, a darker blue precipitate is formed, and this indicates the presence of iron 3 ion in the solution. Take another solution which contains copper 2 ion suspected, and to confirm this, you have to add potassium ferrocyanide. Chocolate color precipitate is formed, and this confirms the presence of copper 2 ion. Confirm a solution contains zinc 2 ion. You have to add sodium hydroxide solution. A white gelatinous is formed. Then you have to add in excess to see what will happen. The white gelatinous formed dissolves. The ammonium ion in solution. And to do this, you have to add sodium hydroxide solution and heat. Then you have to test the vapor with the wet red litmus paper. You have to add sodium hydroxide solution. Then you have to heat the solution, and you have to observe the changes that will take place to the red litmus paper. Okay, the red litmus paper turns into blue. This shows that the alkaline gas is given out, which is ammonia gas, and this confirms the presence of ammonium ion in the solution provided. Here you have the expected results. You have the ion, you have the experiments, you have expected results. To confirm ammonium ion, you have to add sodium hydroxide solution and heat. Then test the vapor with wet red litmus paper. Expected results: smell of ammonia will be detected. Red litmus paper turns blue. To confirm calcium ion, here you have to carry out flame test. You will see brick red flame color. To confirm iron 2, you have to add potassium ferrocyanide solution, then a darker blue precipitate will be formed. To confirm iron 3 ion, you have to add potassium ferrocyanide solution, darker blue precipitate will be formed. To confirm copper 2 ion, you have to add potassium ferrocyanide solution. Or if you don't have this one, you have to add ammonium solution drop while still in excess. But to what you did here, chocolate colored precipitate formed. To confirm lead 2 ion, you have to add potassium iodide solution or potassium chromate. But you added potassium iodide solution. Yellow precipitate formed. To confirm zinc 2 ion, you have to add sodium hydroxide solution drop while still in excess. White gelatinous formed first and then soluble in excess. From these reactions, cation ion, which exists in a specified reagent, which when used gives an observation that indicates only one cation present.